I'm going to create one more function actually so that we could see what the generated samples will look like. So we'll say save underscore generated samples, fake samples, epoch. And we'll say that save images will be torch vision. So we'll be using the torch vision library to perform this task. .utils.makeGrid. All makeGrid does is put your fake samples in a grid so that you could view all of them at one time. And it'll be really nice and convenient. So torch vision.utils.save image, save images. So what save images is a picture that contains all of your samples. And we'll call it epoch plus string epoch plus images.png. So all this is if we're at training epoch 1000, these images will be generated from the generator at that respective training epoch. So again, okay, so I wasn't sure if I wanted to collect these because if you remember in one of the previous videos, we discussed how the loss functions might not mean anything and it's hard to make any sense, but the images will be really good. For now, we'll just collect these losses so that you have an idea of what it looks like. But just keep in mind that the loss functions in GANs are really difficult to use as a metric on performance. So for every epoch, we'll reset the loss for that epoch. So dloss equals 0, gloss equals 0 as well. Then we'll iterate through all the batches. So for batch in train data loader. And this is where the process gets a little more unique, but it's not too complicated. So the Z samples will be generated by calling the create latent vector Z that we created earlier. And here we have the batch size. I don't know if we defined the batch size actually. Let's take a look. We didn't define the batch size here unless. So we should actually do it up here. And then we'll say batch size equals, we'll use 32. That should be okay for now. And then, so we ran that. Now batch size does exist in our environment, so we should be good to go. And then the fake images are simply created by calling the generator on the Z samples. So what you're doing is you're passing the latent vector Z's into the generator, which will transform them into images based on the kernels. We'll say D error equals train discriminator. And what we needed was the real training data. So remember when we had train data loader, I didn't make a new one. So it's in this format, which outputs a dictionary. So in order to get the real training data, we want the lensing images, which was key A. So real train, we'll say lens images is batch access A or key A or whatever. So lens images are the real samples. We have the fake samples as well. And then we're also taking in D, the discriminator, the D optimizer, and the criterion, which is our loss. I called it criterion. Then we also want to generate the G error or train the generator as well. So then we'll say fake samples, D, G optim this time with the criterion. We'll say D loss plus equals D error, G loss plus equals G error, and I think we'll be good to go there. So let's just append the generated losses to our arrays so we could see what that looks like later. And then we'll say if I mod 200, all this is saying, or equals 0. All this is saying is that at an epoch where when you divide it by 200 there's no remainder, let's save those images. So if you're on epoch 200, 400, 600, 800, it'll start saving those images. And the reason I want to do it every 200 epochs is because it takes a long time for the generator to improve, and then we also want to see how it progresses over the training period. So we'll call the save generated samples, fake samples on epoch I. The reason I didn't do anything here where it's like images equals is because, for one thing, we didn't return anything from this function. And then also what we wanted it to do happens already in the function. It's going to save the images to our Google environment. And yeah, we don't need to output it into the code. Okay, so after it's done training, what we're going to want to do is plot the GAN loss. So again, we're not going to expect anything, but I think it's still a good idea for you guys to know what they look like and how to maybe understand it for yourself. So discriminator loss, plot G losses. Legend show. Okay. So actually I don't know if we need the save figure here because it's going to show it in our notebook anyways. So let's try to run this. Hopefully it runs on the first try, but you know how that goes. Create latent vector. Create latency. Did I not run this? I guess not. So okay, so I think what happened here is, remember our images again had to come out as batch size, so 32, 3 channels, 64 by 64. The problem when we created this latent vector Z is that it's coming out as 32 NZ, which was also 32 and 1. So what I did here, before it was only a single one, and I think we need to add another one here. So hopefully that fixes it and we could start training. And it seems that we forgot to pass something to the GPU, and if torch.cuda is available. So the problem here is our generator is on the GPU, but the Z samples that we created aren't. So we'll say Z samples equals Z samples.cuda. Okay, and it seems I also forgot to put the real images on the generator or on the GPU. So let's do lens images dot CUDA. Let's try running that again. So I'm not sure if this should happen because they're different optimizers, but I guess they're being held on the same graph, and that's messing with the training process. I'll try to verify this later. If our images don't come out nice, then that's probably something we need to take a look at. But let's try running this. Retain graph. I put it in the wrong place. Just a ton of errors today. Okay, so the thing about this is when we split up our batch, dude, there's just a ton of errors here. 32, 32, 32, so that's 96 plus 32. So this is 128, I believe. So the next batch to create a data set of 150 images will be 22. So what's happening is that we have a batch size of 22 for the labels, but then our batch size was 32 here. So what we need to do is say n, or we could put it here actually. We'll say lens images dot size 0. And basically that means whatever the batch size of the real images is at that point, just use that to create the same number of latent vector z's. And I think that will be it. Save generated samples is not defined, and I misspelled it. Generated. There's so many errors today. I am so sorry. But this is the reality of coding. I think a lot of people will agree with you that there's a lot of random errors that could come up. And sometimes really simple. You would want to try to avoid those because they could waste a lot of time. But we're also trying to do this in a very short amount of time. So I'm gonna pause this right here because I noticed that we're not getting an update. And again, I forgot to print an update message. So epoch, let's say we'll say string I, where the discriminator loss is D loss, and then we'll do the same thing for the generator. So we'll say generator loss G loss. And I just want to verify that everything here is correct. Okay, so now we're getting updates. And you'll see that the losses here, for the discriminator it's low, but for the generator it's pretty high. And yeah, it's hard to make any sense of it, but at least we know what epoch we're on. And what we'll do is when it's done training, we set 1500 epochs. That's going to take a while, so feel free to do something, watch some other videos on your free time, and we'll come back when this is finished. Okay, so our network completed 1500 epochs. As you can see here, this loss graph is kind of strange, doesn't make a lot of sense. But the moment of truth, let's download the, the grids that we generated. Let's download the samples that we made and let's see what they look like. So to do that, we'll say files.download, and on our environment, remember we saved them in this format, epoch_0 images.png. I don't know if there's a more efficient way to do this. I mean, I guess you could use a loop function, but we're just going to do it one at a time. Okay, so here we have our images opened up. This is epoch 0, and hopefully we'll see that as training progresses that these images get better. So here's epoch 200. Yeah, you could start to see the lenses forming around the center galaxy. This one's a little weird, epoch 400, but sometimes that happens, and that's the reason we would like to look at more epochs, because sometimes a training iteration might generate this mode at first. So let's go to epoch 600. Okay, it's a little messy still, but that's okay. And these are already a lot cleaner. You could start to see a little bit of mode collapse here. So notice how a lot of these samples have this feature, and those images have the same lensing features over here on the side. And that's exactly what mode collapse is, where you start to produce too many of the same samples. So here again, these features are exactly pretty much the same thing. But let's keep going. Okay, so here's 1000, a little better. I think there's less repeats except for this one over here. And then here's 1400. So it's not as clean as we would have liked it to be, but you could see that there isn't that much mode collapse anymore. It actually escaped that problem a little bit. Now, one thing I do want to point out is the problem with the rotations. You could clearly see that it generates some random void of an image on the corners here, and that's because we rotated the images and it's copying that. So I think when you're generating images, you want to make sure that you don't have these empty spots in your image, because the network will learn that and it's going to try to produce that, and seems to produce it randomly, unfortunately. But yeah, we successfully created a GAN that's able to produce images of gravitational lenses. So I hope that was really cool. I hope that was really interesting to you. Let me know. But in the next set of videos, this is the most basic form of a GAN, and over the past couple years we've started to add more things to it. This includes the conditional GAN, which is better for reasons that are kind of intuitive. We have the UNet, skip connections, residual layers, ResNet, and we're going to learn all of that so we could see if we could train a GAN to try to learn physics, basically. So I won't go too much into detail on that. You'll just have to watch the next couple of videos. But with that said, I hope you enjoyed this one, and I hope to see you in the next one. Peace.